Okay, so we did have an introduction, but this is Justin Shepard. He's principal architect at Rackspace. I've been working with Shep since 2008. So to say that, a long time. I'm Joe Breu. Now I'm a dev team lead. I am traditionally a technician or a Linux tech, and not really a good programmer, but I'm a really good ops guy. So I'm the ops buddy. So a little context before we get started on talking this. So Rackspace Private Cloud builds and deploys OpenStack clouds for customers, either in a Rackspace data center or a customer-owned data center. So we run OpenStack for customers. We've been doing it for about 3 years, right when OpenStack got started. So right when kind of Breu came out, we flipped over and started offering it as a service. So this talk is kind of some of the stuff that we've gone through with the dev and ops team and lessons learned, what has worked, what hasn't worked, things that we've done bad, want to change.
Yep. So the way that our groups are laid out right now is we have a support team. The support team is responsible for the day-to-day operations of people's clouds. These clouds could be in the Rackspace data centers, in any of the Rackspace data centers around the globe, as well as in customer data centers. So I actually have a few of my customers in the room here, and they're all customer data centers. So awesome. So our support teams, they will manage your cloud for you. They are 24/7, watching for alerts and responding to alerts and resolving issues that come up with your cloud. And as well as you can call them up at any time, day or night, and ask them questions like, how do I do something?
And this broke, please fix it.
Yeah, this broke, please fix it. And then we have the dev team, and Shep and I are part of the dev team. Our job is we create the tools for automation for deployment of these clouds. Right now that is Chef, as well as a bunch of Python and a bunch of Bash that all fit together to do a deployment. And we also make decisions about new software that is coming as part of the OpenStack ecosystem. And we make a decision about whether we think that piece of software is good for integration into our product. Good.
I think it's stable.
Stable.
So that is where, inside the OpenStack ecosystem, right, there's new projects that spin up all the time. And some of them can have, 10 developers writing something that think is interesting all the way up to a whole bunch of companies going, this is actually interesting and backing a new project. And as it comes out into what they kind of call release quality, the dev team gets first responsibility of going through and saying, okay, this is not horrendous. This can actually be run and be operated. It's going to have bugs, but it is of some certain grade of quality to where it's not going to burn your cluster down whenever I install it. That is not the operational bar. So there's a big difference between when a dev team says this is something I kind of feel comfortable putting in a customer's environment versus this thing works as I would expect for a production environment. So that's where the ops team really kind of comes in. And by production environments, we usually mean environments that are going to last more than 5 minutes, because most of our dev is on very short-run, short-lived clouds, as well as the OpenStack dev is very short-run, short-lived clouds. And a lot of times we run into the problem where, as we run these things for a longer period of time, we run into problems with operational stability over time as more data, for example, like Salon code. We'll just leave it at that. Okay. So, when we started as Rackspace Cloud Builders, Shep, myself, we had 3 other guys on our team. We were the experts at deploying OpenStack. We worked very closely with the Ansel folks. The Ansel folks were the guys that started OpenStack, as well as collaboration with Rackspace. We were the subject matter experts flying all over the place, installing OpenStack clouds for all types of customers on all types of different machines and all types of different networking configurations. It was very pro-serve-ish type of model, where we would go in, have a phase where we would sit and talk with the customer, figure out how everything's going to be wired together, and then figure out how to wire in all the OpenStack components together. A lot of times, that involves some really interesting things, like we find a bug that only happens in this particular type of environment, this particular type of network here, and we're actually going in and making changes to the Python code for OpenStack on the fly. That's gotten better, but we try not to do that anymore. Those are the very early days. So we
I think as a group we did 10, 15 deployments on 5 continents.
And so for 8 months, we deployed to 5 continents. I think we actually did 30.
30 months, okay. So, and a lot of those were really interesting deployments. One of them, just a side story, one of these deployments we had to go in and ship all of our data 3 days in advance so that they could scan it before they let it into the data center. Another deployment that we did, and this one was, we had no network access from the thing that we were trying to deploy. We had absolutely no network access. And that wasn't by design, that was just while when we went in there, this stuff wasn't cabled up the right way. So we eventually got that fixed.
So over time, that's not necessarily super scalable. And we had 5 or 6 guys flying all over the world doing a bunch of bespoke cloud installations. And so as we started to productize, we built an ops team. So this is the thing that today people know as an for OpenStack Cloud. These are the guys that Joe was saying earlier, are watching all your alarms, responding to tickets. They're the guys that you pick up the phone and say, this is broken, help me. Now, the interesting thing is, over time, these guys are the ones that are running the clouds. We're not anymore. So we know, on the dev team, we know OpenStack, and we know kind of how to assemble it and how to install it. But as far as best practices and lessons learned, whenever you've been running it for a while, that now became an ops team.
Yeah.
And so we're still producing tooling to lay down OpenStack and trying to get all the best practices in there, although we are not the subject matter domain expert on the best practices in more of the ops stack.
Yeah, once it gets in the wild and people actually interact with it from a user and operator perspective, the things that we do as people that put together the operational tooling to deploy these things changes based on their feedback. And so that was one of the problems that we have is how do we get that information from these guys and how do we deliver that back up to us as a dev team, and then we can re-deliver that back down as code or procedures or things that can help them make their jobs easier.
And this is your classic DevOps problem, right? You got a bunch of devs, you got a bunch of ops, your devs are producing something kicking over the wall, ops guys look at it and go, this is terrible, why do they hate me? But, they don't understand it, this is going to wake me up at 3 in the morning. So we went down trying to figure out how to fix this. Like I said, you get very simplistic things that the ops people know. I mean, we're setting default attributes for OpenStack config variables inside our code flows. These might or might not be good defaults for running a customer. And this is a very simple explanation of it, but if I want memory overcommit on my Nova cluster, let's say I set it to 4 to 1, and our ops guys have learned that for the standard gear that we ship in a BOM, maybe 8 to 1 is actually a best practice for most customers. It hits 80% of the customer use case, or maybe it's 1 to 1. And actually for memory, they found that
2 to 1.
Yeah, that 2 to 1 is actually the best option. So we spent a lot of time struggling with them to try and get everyone working together and how we pull their best practices back into the code and get it shipped back out to them so that they're not fighting with us. And we've got the best practices in the code. That's what everyone wants.
Yeah, and the reason that's so hard is a lot of these, say we have 200 deployments. While it's our goal to have these 200 deployments, even 80% of these 200 deployments to look the exact same, in reality what we end up is with 200 snowflakes. Every one of them is just minutely different. Every one of them wants to do something just a very little bit different. And every one of them wants to bring in some piece of networking or other storage or physical gear that's just a little bit different than what all of our other ones are. So we have to be very generic when we make these configuration options, but also be very detailed enough to be able to represent them correctly when we're doing our attributes. And we have a really hard time doing that sometimes.
So on the we've gone over this for 3 years with these teams, trying to get them to work together and collaborate and get, kind of the DevOps mantra working for these things. Fun story, found out that it doesn't always work right. Like if you have a team of sysadmins, like trying to convince them to write code, it's sometimes difficult. And or whenever you have a dev team that slaps the hand of sysadmins because their code does not meet the requirements or the style guides, and they kind of get annoyed and stop writing code. So we've gone over a couple of different ways of working with them. We did it on a rotation with them, where we bring one ops guy into a dev sprint every 2 weeks and rotate through, and so they were actually trying to take items off of the sprint boards and work through them. That worked well for some people, it worked horrible for some people. It has to do with their capabilities. Some of them were a little more inclined to being able to write code. It worked pretty well. The ones that weren't, it was very stressful for them. We've gone through a couple different other options. The one that actually worked the best for us was the airing of grievances. So we set up a time every month or every 2 weeks where we just got in a room. And it was, all right, bring your list of things that you hate us for, and let's talk through it. And so, 3 or 4 of the ops people would come show up with their list of these are all the things, and this is why you hate me, and let's go through them and fix it. So that was actually the best solution that we came to.
They had really good reasons to hate us.
Yeah, they did. But it actually got to where we started getting a cycle every 2 weeks where they were coming and saying, like, why do you have this value set this way? You guys are waking up before because you're doing this. Okay, well, sorry, we'll fix it for you. And so we actually got a feedback cycle going with the airing of grievances where they were coming on a regular cadence and pushing up their best practices so that we could put them in cookbooks. Not exactly the story you expect to hear, but that's kind of the one that worked best for us. Yeah. One of the other problems that we've had with this whole thing is the flexibility versus standardization. So ultimately we have a product team that is building a product that we're distributing to customers. It's a little bit non-standard off-the-shelf software. It is, doesn't quite fit that model, but inside of OpenStack, it's super highly configurable. I mean, Nova alone has got over 1,000 config options. It's got support for 4 or more hypervisors, if you don't consider containers a hypervisor. Like the Neutron networking service has got over 15 platform plugins. So you can do everything from Open vSwitch to Plum Grid to VMware's NSX to Linux Bridge. The storage platform, Cinder, has got over 20 different plugins. So that's everything from a NetApp to a SolidFire to an HP left-hand SAN to EMC, VNX, and VMXs. So we kind of had a hard time trying to figure out how to walk that tight balance of giving customers the flexibility with a bunch of different options, but also having something standardized to try and combat the snowflake approach. We did this in a couple different ways. One of the ones we did is on our KVM system, or for our hypervisors, we chose KVM. We don't do any other hypervisors, so we eliminated all the options there to try and get to a standardization. The reason that we did go with KVM is, there's a bunch. One, it's got the best support in the community. So it's what's tested all the time. It's what gets the features the fastest for OpenStack. Sorry. It's got one of the better communities for the open source variants that are out there. Inside of the OpenStack community, you have kernel programmers that are also part of the distributions that work on KVM, and you've got a really easy channel for getting bug fixes in a very quick time frame. But as far as our perspective, the skill set was what attracted us to it. I can go and find a Linux guy or gal and pick them up, plop them down in this environment, and all of the tools that they expect to work in KVM. If you go with a Xen server or a VMware, that's an entirely different skill set. I mean, all the tools kind of may look Linuxy and may be kind of familiar, but there's a lot of weird variants. You end up having to train them for a different skill set. So going out and trying to find those people, while you can find VCPs and you can find people that come from Xen server, finding Linux guys and gals is pretty easy. They're all over the place, and inside of Rackspace, we have a ton of them. Yeah, we have a whole lot of them. And so we really were able to just kind of pick them up and put them in with very little training, and they are able to do all of the day-to-day tasks that you need to, and they're very competent in it because the entire hypervisor is based off of its stock Linux toolset. That was a big attraction for us. Another example for the storage platform, let's say that we went with NetApp initially. We ended up supporting a couple of more. But one of the reasons we went with the NetApp option is not because it has the best feature set. We had an in-house storage team for NetApp. So I had an entirely team that I could leverage. I didn't have to build any training on my side. I had an entire support team dedicated for other parts of our business for customers to call up and say, I'm having a problem with this NetApp storage. I was able to just pick that up and use that as is. So not based on technology, based on usability. One of the last things on that is, on the storage piece, we added a couple other ones, right? So we had a EMC function inside of Rackspace as well. We had a support team that was dedicated to supporting those, so we added those. As you do that, you're doubling, tripling, or quadrupling all of your effort. So all of your test cases now have to run against, let's say we did NetApp and EMC as our 2 storage mechanisms, we doubled the entire matrix. So we have to run all of our sets against the NetApp and then the entire thing again as EMC. And with automated testing, this isn't horrible, but it does duplicate effort.
And it takes time.
It does. And if we did a hypervisor, now all of a sudden you're going from 1 to 2 to 4, because I have to do 2 hypervisors and 2 storage platforms per hypervisor. And you end up with 8 if I'm doing my math right.
Yeah, and we also test for neutron and open network. We test in non-HA and HA.
So you end up with this really large, gnarly mess of matrices, all because a sales guy said, I can win this deal if you have this storage platform. So you have to be very, very restricted whenever you do make the choice to add another variant because of all the ramifications it has. And so the last point we had was add it whenever you have customer demand, but you need to have significant customer demand because it's very painful to do so. It needs to be worth a lot to you to make that choice. It's not something you do lightly.
So we have been writing chef cookbooks for OpenStack for around 2 years. And when we started, obviously a lot of the stuff that we were writing for didn't exist. Even the community StackForge cookbooks are originally a fork of ours. They've diverged a lot since then, but they're still originally ours. So in that 2 years, obviously we have had a lot of technical debt that we have carried around, but in total, our cookbook set to deploy a working OpenStack cluster is right around 61,000 and change lines of code. That's Ruby, templates, extra files that we're shipping around, and that's not counting any of the upstream cookbooks that we also consume. So that 61,480 lines of code is pulled from 32 of our own cookbooks. These are all open source, by the way. But we also pull in 22 upstream cookbooks. So with a total, we have 54 cookbooks that we use to deploy OpenStack. So with that, we've run into some problems. So with 54 cookbooks, obviously, we can control the ones that we have. We can control the 32 that we have, and on every single commit to every single one of our cookbooks, we run a full integration test. That's end-to-end OpenStack for Ubuntu and CentOS. But we only test HA, because if HA breaks, then obviously non-HA is going to break. But what we've run into problems is, we've made mistakes and set incorrect parameter names. We've made spelling errors and that type of stuff. Those are things we fixed. We have had problems when the way that we have done our templates, which are basically like monolithic templates, that when we want to add a configuration value, whether it be from support's request or customer request, it almost always, and definitely does take a release cycle for us to get that done. And we know better ways to do this. This is just technical debt that we've been carrying around for a really long time. Other problems that we have is we test all of the upstream cookbooks that we consume on a daily basis. We find errors and bugs that have come into some of those cookbooks, and we report those upstream. There's also some bugs that we have found and tried to, and actually submitted code to, that still haven't been patched upstream. I love ops code, like Chef, I love Chef, but Cook 2676, if there's anybody in here from ops code, like I need that fixed, please. It's 1 year old next week. So because of that, we have actually forked and maintained our own branch that has this fix in it, and it's a very crucial fix that we need for setting up rapid execution, which is terrible, but fine, whatever. So we find issues with cookbooks, and we have testing around those cookbooks. We also find issues in upstream OpenStack projects. So we part of my team and part of the other teams that work in my group, we have the Keystone Primary Technical, or the PTL, he's the project team lead. We also have now the Nova project team lead. So we have two of the 5. What did I do? You almost fell off. Oh no, I'm good. We had 2 of the 5 core OpenStack projects. When we find issues with the clouds as we're running them, like I said earlier, when we were doing our own deployments, we'd find problems. We would fix them on site, and then when we send those upstream. We still find bugs even today, and some of them are really interesting, and some of them are just how did this get in, and why did you do it? We're also finding bugs with upstream operating system packages. So this would be vendor X or vendor Y, I won't name them, but a lot of times they break things upstream and they push them out of the wild, and now we can't deploy our cloud until we get that fixed, which is very frustrating. And then we also find fundamental flaws in foundation technologies. We use RabbitMQ and MySQL as our database and messaging bus. and we find really interesting and gnarly bugs in some of those software packages as well. What we have though is we have a problem when we find any of these bugs, is that getting this stuff rolled into upstream and then back down into the vendors so that we can deploy them back into the clouds that we built takes time. So we still haven't really figured out that problem.
Well, before you go to the next one, I actually think it's an important thing to discuss real quick on that is whenever you're taking on something like this, you do end up having to own some of that. So as we're delivering a product to the customer doesn't necessarily care that operating system X broke the Rabbit package. They just know that my cloud's not working right. And so you end up having to staff appropriately to handle fixing that upstream, managing it through the upstream changelog process, getting it merged into the upstream code path for Rabbit as an example, and then following that into the different operating source vendors' packaging channels, coercing them to get packages out on time, and then getting that into your cookbooks and any kind of band-aids or updates that need to be made to your cookbooks to allow this new package to come through. Rabbit is a good example. The weird side effect on that is if you weren't going after an upstream problem, so let's say you didn't have a problem in Rabbit, the code base itself, you had a problem with one of the community cookbooks. A lot of times you're having to chase that through with Chef, and they're super responsive on fixing issues and working with us to get it patched. Once that gets released, it'll go into the next version of the cookbook on the community side, right? So now .14 instead of .13. Well, that fix is not the only one that's in there. There's 12 fixes in the next update. So I pull that in, and I get my fix. And I got 3 more bugs. Circle goes, circular argument, continue, rinse and repeat. So there is a staffing concern there because you're doing this. You have to have staff to go through that process.
Okay. So I guess we do name the names. Like we had this problem with Ubuntu, we have it with the CentOS and Apple, we have it with Red Hat.
Everybody.
Yeah, everybody. But we have the usual problems. Like these are things that we've run into almost every single time. And I was talking to one of my colleagues out here earlier before the talk, but there have been so many times where we've gone through our full QE test of our very large matrix of things we're going to test. It's all physical hardware, so it does take time to re-kick it. It takes time to run these tests. We do burning tests. We do long-running cluster tests. And the day before release, one of these guys rolls out new packages, and it breaks something. Or maybe it doesn't break anything, but we have to restart all of our QE tests. Because when customers go to deploy these things, when our support teams go to deploy these things, they're going to be getting this latest package. And we need to be able to tell these people that what they're deploying is what we're testing.
We tested this version of the cookbook, so these versions of packages, and this version of operating system, and you've got it.
So when they change it out, when they pull the rug out from underneath us, we have to go back and do all this again. Sometimes they introduce a bug, and it could be an upstream, it could be an OpenStack bug, it could be a operating system vendor bug. We have to either come up with a workaround for that bug, or we have to turn around and report that back upstream and wait for that fix to come out before we can break that blocker. We have Ubuntu, we have Breu and CentOS. Breu and CentOS can kind of get combined together because they use Apple for the OpenStack stuff, but they have independent packaging processes. So Ubuntu has their own release cycle, Apple has their own release cycle. We've tried to embed ourselves deeply into the Apple release cycle. It's hard, but we've done it. For the Ubuntu one,
We're embedded there too.
We're embedded there as well. But their release cycles are completely different. They release on different days, they release different versions of the packages, they release the same version of the package with different code, which we found several times in the past. Sometimes they pull in 5 bugs over here and 4 bugs over here for fixes, and we're left trying to figure out which ones they still didn't fix.
All right, so release schedule. This is another problem that you have whenever you're kind of doing this, is how do you figure out your release dates for your customers? With OpenStack, they have a 6-month release cycle, so there's a new stable code release every 6 months. We try to support the last 2, so if you're running Havana, we also support Grizzly. Whenever Icehouse comes out, we'll support Icehouse and Havana so that we're not making customers update every 6 months because they yelled at us when we asked them to do that. there's also a bunch of minor version releases that come out. This is just the OpenStack piece. So OpenStack will come out and say, all right, I've got Havana.1 and Havana.2 and Havana.3 during that 6-month cycle. Joe was talking about a minute ago where the packages of the software don't all contain the same thing. So whenever Havana.1 comes out, you might have Ubuntu taking a package cut that's 2 days after that as far as the Git repository is concerned. Red Hat took one that's 12 days past that, and so you've got really inconsistent code across all of them.
And then brought in their own patches.
Yeah, and then they also do like wonderful things like make their own fixes. And so you have this weird scenario where you're trying to figure out how to handle your release schedule. So that's the OpenStack thing. Now I've got to go and figure out, I have got cookbook updates that I've got to fix. So we set down wrong comp variables or some of the other problems we talked about in our cookbooks. I've got to release bug fixes for that. We have got an upstream cookbook problem that we're now pulling in and bringing that in for the QA testing that we were just talking about a minute ago, where you go through the entire stack and test it. I've got to come up with a schedule to be able to get that in my customers' hands, because these are things that are making their life painful. Someone's HA is not working right, or someone's Nova is not booting instances the way it should because there's a rabbit bug. So I've got to get this to the customer's hands. We try to do every other month releases on this. Yeah, okay. So we're trying to do every other month releases on this, where every 60 days customers are getting this. And because we're doing 2, we flip-flop it. So Havana's on a 60-day cycle, Grizzly's on a 60-day cycle, but they're not on the same one. They flip-flop, right? So go do Havana, go do Grizzly, go do Havana, go do Grizzly. This has worked pretty well for getting it in the hands of customers. We definitely have found that across the swath of our customer base, we've got customers that this is entirely too fast, and we've got customers that this is entirely too slow, which is often because you can't please everyone ever.
Yeah, customers running Folsom still?
Yeah. Yes, we'll find top customers that are like, I don't want to ever update for the next 4 years. So I've got you've got all those customers, so that you can't please everyone, and you just have to pick something and go with it, and really try and stick with it. Fun thing is this is the easiest decision in the world to make. It's the hardest one to get right. So whatever you pick, you're wrong, and just deal with that. Hopefully you please a significant portion of your customer base. That's the best you can make it, hopefully. So we've changed this a bunch of times in the last 3 years, where we've done different release cycles based on different cadences. This is the one that we've been doing for a little while, and it seems to be hitting the 80-20 rule. It generally makes most of our customers happy, and the fringes we can kind of deal with fringes.
Doesn't make my release manager happy.
No, it doesn't. It also is probably not a good thing we're going to keep. Like, we will probably change this again. Like I said, this is the toughest thing to get right. And if you're really interested, our release manager is actually in the room, Clucko. He's presenting at 2:50 in the Regency AB tomorrow, and you should ask him about this after this. He loves talking about release management.
And versioning.
So,
Okay, so you've got it deployed, right? Chef server deployed, you got your full OpenStack node cluster deployed, you've got a couple controllers, you've got 55 compute nodes. How do you do upgrades after that, right? So we've talked about, we have some customers that never want to upgrade. We have some customers that are fine upgrading every 2 weeks, even if it's minor or major package versions. They're like, they're rip roaring. They get the new feature. They want it fixed fast. They don't care if they destroy their cloud, because they're using their cloud. It's a cloud should use, and that's things that they're using them as cattle, not pets, right? So every 6 months, this has been our experience with OpenStack at least. We've had packages that have been renamed out from underneath us. We have different operating systems that use different package names. We have different operating systems that have different names for different types of dependencies, and even some of those dependencies might be split into multiple different packages. It's a nightmare when we go to release a new version. We've had services get renamed out from underneath us. So from Grizzly to Havana, we were using Quantum as the network driver in Grizzly, and apparently that name was trademarked. So we had to change it to Neutron. We made some very poor short-term decisions when we were first building out these cookbooks, where we decided we're going to name our attributes the name of the package. And that was a bad idea. Like, if we would have been able to take that one back, we definitely would take that one back.
Well, to be fair, we did it wrong twice.
It was your fault. So, yeah, everything's Chef's fault. So, when we were doing these upgrades, and I'll talk about this in a little bit, but we had to come up with another tool set so that we could facilitate the upgrades from Quantum to Neutron and still maintain the attributes that we had on each of these nodes. We also have projects that get split into their own services. So when we were doing Folsom, we had Nova volumes, and that got split into Cinder, which is a completely different service, completely different package set, different dependencies, as well as entirely different attributes and templates that we need to lay down inside the brand new cookbook. Nova Network was the same way. However, Nova Network's a little bit different because Nova Network was deprecated and then it was undeprecated when Neutron didn't move fast enough. So now we're carrying around both Nova Network and Neutron, and we're going to have to go back and fix all of the things in Nova Network that we're kind of hoping were going to go away with Neutron. And then we have one that we know is going to be renamed in the future here, probably in Juno is going to be the Nova Scheduler, and that's going to be called Dance for some reason. Okay. So inter-release upgrades, like I said before, we had the quantum and neutron problem. One of the guys on my team actually wrote a really cool tool called the Mungerator, which was a joke when we were talking about it, and like this always happens and it's stuck. But what it is, it's an attribute munger that takes attributes that were in our old Grizzly configuration and our environments and node attributes and converts them into the new format. And does some other things that help us with upgrades like database backups and stuff, pre and post, so that we can make sure that we upgrade these things with minimal risk. But the attribute Mungerator was terrible, and we're probably going to have to do it again in the future. I have no doubt we're going to have to do it again.
But the lesson there is namespacing.
Yeah,
we good, good.
But we called it quantum to neutron, so we still didn't learn.
Yeah.
So also inter-release upgrades, like this is even going from Grizzly to Havana, obviously, you're going to find more bugs. But like it's a new version, so it's not really a bug, it's a feature, right? We found a really awesome bug going from Folsom to Grizzly, and that's where I could actually DOS the scheduler by doing simple things like ask it to create an instance. Or 5 instances or 10 instances, it would end up filling up an entire compute node, which wasn't what the scheduler was supposed to be doing, but because they wanted to increase the performance of the scheduler, they made it multi-threaded. By making it multi-threaded, if I send in 5 schedule requests, all 5 of those schedule requests make the exact same decision about where it should place the instance because they all have the same view of what the data was when they started the schedule. Terrible bug to track down, and finally got fixed. Thank God. Even OS upgrades. So Ubuntu is a little bit better. Upgraded the operating system, obviously. Going from 12.04 to 14.04 isn't going to be that bad, but going from RHEL 5 to RHEL 6 to RHEL 7 is terrible and usually means building a bug. Yeah. So, like I said before, we have some pretty significant testing that we do for our cookbooks. We also do significant testing in the upstream cookbooks. We do some stuff like pep8 for Python and Food Critic for the Ruby for the cookbooks. We do a full deployment of OpenStack. Each and every commit that we do is a full deployment. Now we do this virtually, so it's not that big of a deal. We have some resources that we throw at it. And it's a very generic, like a smoke test. Make sure that the cookbooks don't have any syntax errors. Make sure that all their searches and config files get laid down. And then once everything gets laid down, then we run a full test against the OpenStack to make sure that whatever we just added didn't break some functionality that we're already selling to our customers. So that would be the functional test of OpenStack. We also do API testing and CLI testing, so we have written 2 tools. We will be moving to Tempest and the other ones that are out there soon. We just haven't gotten around to it. But we have written these tools that just basically do, can I boot an instance? Can I look at the instance? Can I destroy it, snapshot, etc. We also test all the upstream cookbooks, like I said before.
So Joe did mention the StackForge cookbooks, and since we're talking about this, we have the system that we use for our cookbooks with testing. You'll see a couple things missing here that as a chef on attendee, you would immediately raise your hand and ask how come I don't see chef stack up in there and test it. So with StackForge, this is where we're trying to get to, and it's not all the way baked, but it's where we want to go for how you test a major system like this with cookbooks. So on every single cookbook change, there's Rubicop testing. You've got Food Critic, so those are both doing your style and syntax checks. Chef spec unit tests against the individual cookbook. A really good step from that is also to do a test kitchen install of that specific cookbook itself with server spec to check that the thing that you're laying down operates the way you want it to. Server spec is actually really amazing with the bats to be able to do that, where you can check for OpenStack. If I lay down Glance, I can run a whole bunch of glance commands and make sure that I can upload an image and I can delete an image and I can give it metadata. So I can actually test inside of, say, Kitchen LXC or Kitchen OpenStack that this all works. That's for that component test. Because this is a bunch of components for one big stack, you also want to add in a full stack test for that one merge, right? So I've got all of my individual tests for that specific cookbook all by itself, making sure that it stands, but it's not a single piece, it's part of a whole. So the next part of that gating process would be to take all of the cookbooks that they are, plus your one new changed cookbook, put that all together and do a deployment, which Joe was talking about how we've done that, where we do a full stack install and be able to verify that the system actually functions.
And then once you're ready for release, so we branch, QE starts testing that, and then we might find additional bug fixes that we have to put into that branch for QE capacity.
That slide definitely.
Yeah. So it is our goal to fully consume StackForge upstream cookbooks. We would like to get out of writing the individual service cookbooks and get into writing cookbooks that are actually useful and provide value for our customers, as well as being able to opinionate our installs a little bit. But that's still in process.
Yeah, unfortunately, there's no value in owning the cookbooks for the components, right? That's the object of the community, to be able to put it out there, let a whole bunch of people work on it. You get the best of all the worlds. You write your wrapper cookbooks to do anything special that you want around this component. So we carried the brunt for it where we had to own it for a long time. We started out with the StackForge project, got that project off the ground and running in the effort that we could eventually dump our ownership of those components and move wholeheartedly over the community piece and only have to carry our specialized wrapper.
So I didn't mention this, I guess, in any of our slides, but our GitHub is, all our cookbooks are on our GitHub. It's github.com/rcbops.
And then the StackForge stuff is github.com/stackforge/cookbook-openstack-function identity network compute. That's all like that. So just go to GitHub StackForge and look for cookbooks. Okay. So we got about 2 minutes.
Do we have any questions? About writing OpenStack, about getting involved in OpenStack, about what is OpenStack?
Yes.
How come you guys are using upstream OS packages for OpenStack rather than packaging it yourself?
Great question. We hate packaging. As much as it would solve all of our problems, it almost drove one of our coworkers to jump off of, I still think it's this very same hotel, but it might have been one of us. So we got very bad packaging.
Right. So I went to the OpenStack operators meetup a couple months ago, where they got about 80 different people that work in companies that install and manage OpenStack for whatever, so public clouds, private clouds. They asked a question and they said, anyone in here raise your hand if you were rolling your own packages for OpenStack? Everyone raised their hand. I didn't, because we already did that. It's crazy. But this is a problem. Like the OpenStack packages for vendors are like you run all of these terrible nightmare problems. You don't have any strict control of the code. You're kind of fighting their processes the whole way down. And everyone ends up rolling their own packages, and it's super painful. So we're actually going down install from source route so that I don't have to do the packages. Craig Tracy actually has got an interesting talk coming up tomorrow as well. He's part of the StackForge projects where he's going to talk about omnibusing the OpenStack packages and using the Chef OmniTruck and Omnibus mentality for it, which is another source deploy install. The nice attractive part of that is I know exactly what SHA I cut from, and I know exactly what is in all my packages across any operating systems. And so I can eliminate the whole vendor problem, so all the stuff where we talked about where I have to go chase off 20 different ways and fight these different 5 bug trackers. I get rid of all of that, and I know exactly what's in every single package. It's not a package anymore, but it's a source install. And I don't have to wait for, if something gets fixed, it to filter down through the system for me to get it. I can immediately consume it, and I can put dev resources on that bug if I want, get it merged into the repo, and have it right there. So it's actually where we're going.
Yeah.
Because it's terrible.
We definitely want to get there.
Yes, sir.
So when I log into the Rackspace portal and I order a service that has multiple VMs, that's like a platform, then where they're all configured, multiple VMs that you talking to each other, like database and apps. How do you write your cookbook so that the provisioning of those VMs and the services are service aware, meaning that they both need to be talking to each other with particular configuration, so that when that service is spun up, that platform service is spun up, the chef governing the cookbook is aware of both of those instances in the configuration.
Yeah. So there's an issue with that, and there's a way to do it. So the biggest problem then is timing, right? So if I go and hit everyone, I spin up a whole bunch of VMs all at the exact same time, Chef definitely has search capabilities, but it is dependent on when a node merge completes before the attributes get up for a search, and then you have the refresh, the indexing timeouts. Whenever you're doing it on an OpenStack cloud, there's an orchestrator inside of OpenStack that's called Heat that allows you to do some of this stuff. So on the Rackspace public cloud, they have some Heat primitives that are Chef primitives. But if you're not running on that one and you're just running on OpenStack, you can do all the exact same stuff. You know, you can do a Burks install for all your devs. And you can actually do dependency mapping and say, I need my database server to come up, and my web server depends on these attributes out of my database server. And you can almost do it as Chef Solo, where you're setting the attribute, the node attribute list before you start up if you want to, or you can continue using a Chef server, but you have very fine-grained control over, and make sure this thing completes all the way before the next one does if you're using Chef searches. And so you make sure that the attributes are in the Chef server, and a search will actually populate properly. So there's two different methods there, but they both kind of work, and it depends on which way you want to go.
Yeah. Do you manage a cookbook as a separate cookbook from like an infrastructure application cookbook, or do you have a service cookbook that is aware of the way that the platform needs to be configured to be
I would say that you would probably want to go down the wrapper mentality. So you're going to hide a lot of that business logic in the top end, and you're using some of the orchestration pieces out to time the Chef runs appropriately so that they happen so that whichever way you're orchestrating, either by I populate a full environment to show all relationships, or I use an intuiting method like a Chef search for relationships, you're just controlling that to make sure that the data is there for either one of those methods. Yes?
This point reminded me of a problem that we had at my workplace. I inherited a orchestration nightmare where we had 5 levels of dependency. It took more than an hour to bring up all the elements of the stack because we had to go through the entire Chef client converter before we would start spinning up the next node. To get rid of all that, I would just go back to practice dating back many years. Identify all the resources ahead of time, map whatever resources I'm going to need, make sure that all of that is available to do the provisioning system work.
Yeah.
And the key to this was to reallocate the IP addresses and allocate the DNS names before I bring up a single node.
Yeah.
Before I start a single Chef client, make sure that I've got all the IP addresses. Now,
So-
this brings up another point, which I wanted to ask about OpenStack, because I'm in a vendor locked in AWS customer company. AWS has just changed out from under me the way all this works. How does this work on OpenStack, and are the fog primitives that I rely on able to reallocate IP addresses, DNS names, and so forth to do this with the tools that you're working with?
So, sometimes. In pure OpenStack, yes, you can ask the network. You can ask the network driver when you're creating private networks to attach to your instances. You can ask them for an IP address. It'll do its best to give it to you. If it can't, or if it can't, or it won't, that's not really apparent. It just gives you a different one. The same thing is true on the public interfaces, so the ones where you'd actually get your external internet access from. It'll try. This is one of the reasons why so when we started, we did the full, when we started, we did Puppet, and we had Puppet recipe, whatever they're called. We did the YAMLs, and we would pre-configure all of the IP addresses and where all the services are going to be. And that was really hard for us to test in our OpenStack environment because our IP addresses are going to be all over the place, and we don't know that my controller is going to be this IP address, and my other services are going to be IP address 5, 6, and 7. So that's why we went to the search route. But like you said, yes, we have to wait for full node convergence. We have to wait. We have to do we call it the 1-2-1 problem, but when we do our infrastructure nodes, we have to do Chef run 1, 2, 1, all the compute nodes, and then everything all in one spot. And we would prefer not to have to do that. So one of the things that we talked about is being able to pre-populate overrides inside of our cookbooks if we know what these IP addresses are going to be, so we can short circuit a lot of the searching. for us to, in our cookbooks, to get this to work, we'd have to remove some of the operational type things that we do, like create Keystone, users in Keystone through an LWRP, where Keystone might not be up yet. But by the time this cookbook runs, it really expects Keystone to be up. So we have to add some a little bit lazier better air handling, lazy failures into this, so it will eventually be consistent. But yeah,
And it also kind of
runs
depends.
it.
There's a bunch of layers of that, and some of them behave the way you want, some of them don't, like, because some of it is super asynchronous.
Yeah. Anything else?
Well, thank y'all.
All right.